Okay, great. So what we did, we've looked at I've just shown you the other way of dealing with the yield variance from an input point of view. Now, we do have scenarios where we have waste. I mean, as you can imagine, let me just go to this. As you can imagine, right? I mean, this kind of takes us back to process costing a little. If you did a bit of process costing, if you put things in a vat and you pour in chemicals, before they come out, you do expect some evaporation. There might just be some general waste in general. So really, so for example, you might expect 10% kind of loss in evaporation. So you put 100 kilograms in of something, you expect 10% to go. So you only really expect 90 kilograms to come out. And that's fair. So if you had spent, I don't know, 100 pounds on these things, you would spread that 100 pounds, if you like, over the 90. That's kind of the argument here. So there is an expected normal loss. And thankfully, that's all we have to consider when we are dealing with this. I mean, if you go back to process costing, there are discussions about things like abnormal losses and abnormal gains, but we are only dealing with normal losses. So we can expect. So this idea of normal loss is to do with output. That's the first thing I want to say. So when it comes to mix, we're not really concerned about the loss. It's really when we come to talk about yield that we need to think about this expected normal loss that we see. So let's do this. So from a mix point of view, this is actually very much similar to what we have always done. Have a quick read. You can pause it and read, but I'll carry on. And then come back to the question. So what we have here is that we're making this product, Synthon, and we have agreed that this will be the standard. These are the standard components, which is a standard mix, really, isn't it? 8, 5, and 3. So you can almost see 8, 5, 3, that's 16. So you can see the mix here is 50%. It is an odd one. This is 31.25, and this is 18.75%. That's the mix. Oh, sorry about that. Right, apologies there. These rude people calling me. So here we are. I was just here highlighting this mix here. So 50%. 31.25 and 18. You can check it. 8 over 16, 5 over 16, 3 over 16 will give you these percentages. Right. So the fundamental question here is that you are expecting your a mix of A. Half of the ingredients should be S1. 31.25 should be S2 and 18.75 should be S3. So let's go over to the next page. So basically this is the quantity that's gone in, and it's about inputs here fundamentally. So let's take this to the other. Let's just get a blank page. So what do I have here? So in terms of the mix, what I have here is a straightforward scenario where you have. I'll put yours in the middle. I'll put what actually happened. What actually happened was this. You had 8284, you had 7535, and you had 3334. That's what actually happened. So that's the total. That's your total. That's what your actual mix, and that gives you 8284 plus 7535 plus 3334. That gives you 19153. Now, what should have happened, what the mix should have been, is that 50% of this thing should have been for S1. So if you take 50% of this thing, 19153, 50% of 50%. So I still have 19153 here, but 50% should be comes out at 9576.5. And then 31%, 31.25% times 19153 should be 5985.3, which leaves us with plus 9576.5 was this minus 19153 leaves us with 3591.2, if you like. This is your combination, 31.25 and 17.75, 18.75. These are the percentages. So this is the mix we should have seen. Should mix. Actual mix. And then we now look at the variance. I'm just going to change my pen color to kind of, oops, pen color. Right. Oops. Oh, I picked the wrong thing up. Second. Okay. Somehow this thing doesn't like my... Okay, great. And let's look at the variance then. So should, and this is what you actually, so this is favorable here. You used less than we expected you to do. So therefore, we find the difference, which is 9576.5 minus 8284, and that comes out at 1292.5. Here, you used more than you should have. So we have the difference here, 7535 minus 5985. Let's start again. 7535 minus 5985.3, which gives you 1549.7. And finally, we have, you used less than you. So this one is adverse. This is favorable. And then here we have 3591.2 minus 3334, which is 257.2. And this is favorable. And then what I just go ahead and do, of course, is multiply this. I mean, I'm told in the question that I hope you're looking at your text. You can see page 386, or it's just the the PowerPoints. This is at 30p, this is at 50p, and this is at 40p. And this is therefore equals to, right? So let me just do that. 1292.5 times 0.3 is 387.75, and then 1549.7 times 0.5 is 774.85, and then 257.2 times 0.4 is equal to 102.88. So we have here a favorable variance, an adverse variance, and a favorable variance. So when I add, well, literally add these two together and take away from this. So just add those together, 102.88 plus 387.75, and take that away from 774.85 gives you 284.22, and that's an adverse variance. So that's the mix. That's the mixed variance. So you can see that because we're talking about inputs, really, the issue of wastage doesn't really come in for the mix, because we're not that wastage is to do with, well, we expected to lose some things, but we're just interested in the mix for now. And of course, as you can imagine, even mix could affect wastage, or output wastage would, but we're just interested in the mix, because typically the arguments again because typically this is an interesting mixed variance. It's adverse. Typically mixed variances are favorable, because you have people thinking, well, I'll use a cheaper element here. I mean, of course, I guess you could imagine someone thinking, I'd use a more expensive bit here. Maybe I'd be able to get a better output. But typically better means more expensive. So however you look at it, we recognize that mix variance has some effect on the output. But here we're just interested in the mix. Okay, great. So that's that. And what we'll do in the next video is we will look at the variance, the yield variance, also this time considering the wastage. Great stuff. See you in the next video.